Hello friends, I welcome you in lecture number 2 on logic. In previous lecture we have discussed about proposition, and now we know that proposition is nothing but a declarative sentence that is either true or false but not both. In this lecture we are going to discuss about connectives. So what is connective? So a connective is nothing but one type of operator, or we can say that logical operator, using which we can produce new proposition from given proposition. So in this lecture we are going to discuss about 3 or 4 different types of connectives. Using connectives we can produce new proposition, and that new proposition is known as compound proposition. So we will discuss different connectives one by one, and we will see their definitions with examples. So first one is negation. So how negation is defined? Suppose we have some proposition, say P, which is a declarative sentence that is either true or false. For example, if I am writing that today is Sunday, then this is a declarative sentence which is either true or false but not both. Therefore, this P is a proposition. Now, what is negation of P? Negation of P is nothing but the statement that we will understand in this way. If I want to write down negation of P, then I will write that it is not the case that statement P is true. So here negation of P is denoted by this symbol, and I will write that it is not the case that statement P, which is today is Sunday. So in this way we can easily write negation of any statement. If P is the proposition, then negation of P is the proposition which is defined in this way. It is not the case that proposition P is true. We will use this notation to denote negation of P. Some books are using these different notations also. All these are notations for negation of a proposition. Now in general we can write negation of P in another different way also. Instead of writing that it is not the case that today is Sunday, we can simply write that today is not Sunday, or we can write that it is not Sunday today. Now whenever proposition P is having truth value T, or whenever proposition P is true, then its negation is false. Similarly, if proposition P is false, then its negation is true. So in this way we can define negation operator, and we can write the truth table for negation operation also. Suppose I want to write down truth table for negation operation, then I can write in this way. I will require 2 columns, one for proposition P and another for negation of P. Now because I have only one proposition, so it has 2 possibilities, either it is true or false, and by the definition, if P is true, negation of P is false. If P is false, negation of P is true. So in this way we can write the truth table for negation logical operator or negation connective. So they can ask you to write down the definition of negation also. You can write systematically, let P be a proposition. The statement, it is not the case that P is another proposition, and it is called negation of P, and it is denoted by this type of different notations, and we will use this notation in our lecture series. This is example which we just discussed, and we can write truth table for negation also. there are two possibilities for proposition P, T and F, and negation of P has truth value that is opposite of the truth value of proposition P. So if P is true, negation of P is false. If P is false, negation of P is true. Another logical operator or connective is conjunction logical operator, and conjunction simply means and. We are using this and operator in general language also, so it is same as conjunction in the language of logic also. Suppose I have two propositions denoted by P and Q, then conjunction of P and Q is denoted by this notation, and it is defined in this way. This P and Q, which is another proposition, is true or it has truth value T if both P and Q are true. If both P and Q are true, then only P and Q is true. So this is how we define conjunction logical operator or connective, which we known as conjunction. If they ask you to write down the definition, you should write in this way: let P and Q be propositions. The proposition P and Q denoted by this notation is new proposition, and it is true when both P and Q are true and is false otherwise, and this proposition is called the conjunction of P and Q. For example, suppose I am taking these two propositions. P is it is raining today, and Q is there are 20 tables in this room. Then conjunction of P and Q is it is raining today, that is P, and Q, that is there are 20 tables in this room. Suppose we want to write down truth table for conjunction operator, then we have two propositions now, and therefore we have different possibilities. First possibility is, suppose proposition P is true and Q is also true. Another possibility is P is true and Q is false. Now we have taken 2 times T for proposition P. Now we consider, suppose P is false, then Q can be true or false. So if I consider F here, I will write F here. So you can see there are 4 different possibilities, and I have written all the different possibilities for 2 propositions. In general, remember that if we have n number of propositions, then the number of possibilities like this in the truth table will be equal to 2 raised to n. Here we have 2 propositions, therefore we must have 4 possibilities for these 2 propositions in the truth table. Now how we write down the truth value of P and Q? So we remember that P and Q is true whenever both P and Q are true, and it is false in all other remaining cases. So there is only one possibility in which both are true, and in remaining possibilities we can see that at least one is false. So here I will write F, here also F, and here also F. P and Q is true whenever both P and Q are true, otherwise it is false. So this is about conjunction logical operator. Now next logical operator is disjunction logical operator, and it simply means or. We are familiar with the word or in English language. So whenever we have 2 propositions P and Q, then P or Q is another proposition, and it is true if at least one of P and Q is true. That is, either P is true or Q is true, or both are true, then P or Q is true. So that is the definition of disjunction. Let P and Q be propositions. The proposition P or Q denoted in this way, it is read in this way, P or Q, is the proposition that is false when P and Q are both false and true otherwise. Or we can say that P or Q is true if either P is true or Q is true or both are true, and it is known as disjunction of P and Q. So here I have taken two propositions. Suppose P is today is Friday, Q is it is raining today, then disjunction of P and Q is P or Q, that is today is Friday or it is raining today. So here P or Q is true if it is Friday today, or if it is raining today, or if it is Friday today as well as it is raining today. So P or Q is true if P is true or Q is true or both are true, and in other words P or Q is false if both P and Q are false. Now there is one before that we see truth table for disjunction. So as I discussed in the topic of conjunction, we have to write different possibilities. We will remember this manner. We will write different possibilities. First we write TT for P and then FF. Then here there are two possibilities, T and F. If P is true, Q is true, P is true, Q is false, then here also two possibilities, T and F. So this is for conveniency. It is not necessary that we should write in this particular manner. If we wish, we can write last row as first row also, but this is just for simplicity. We will remember in this way. Now P or Q is true if at least one of these two has truth value T. So here we will have T because both are true. Here P is true, therefore P or Q is true. Here Q is true, therefore P or Q is true, and here both are false, therefore P or Q is false. P or Q is false if both are false, and if you remember this P and Q is true if both are true, and here P or Q is false if both are false. Now we have one important remark for this disjunction operator. Here in disjunction operator, whenever we write P or Q, we are using this word or, but in general or in language, this or has two meanings. It can be inclusive or it can be exclusive or. Or has two meanings in general language or in English language, inclusive or and exclusive or. Inclusive or means if I have two propositions P and Q, then P or Q is true if either P is true or Q is true or both are true. But if we have exclusive or, then exclusive or is true if P or Q, that is if P is true or Q is true, then only we have exclusive or as true. So here we are not including this P and Q. In inclusive or we are including P and Q like this. Here we have written T, that is P and Q both are true, but here we are not including that option, not both. So this, whenever we are writing disjunction, that means we are using this inclusive or, and P or Q is true if P is true or Q is true or both are true. And if we have exclusive or, then we have these possibilities. Exclusive or is denoted by this notation, and this is true if P is true or Q is true and not both. If both are true, then exclusive or will be considered as false. For example, if we are considering this statement that I shall watch the game on television or I shall go to the home. So this is the example of exclusive or. Either I shall watch the game on television or I shall go to the home, but I cannot have both the activities at the same time. So whenever we have exclusive or, then I will not include both the possibilities. If there are chances of both the possibilities, then exclusive or will be considered as false. So whenever we are writing the truth table for exclusive or, suppose I am writing TT FF, here I have TF TF, then exclusive or is true if exactly one of the two propositions is true. That is, here P is true and Q is false. Here P is false and Q is true. So here I will write true, and in remaining cases I will consider F. Here both are true, therefore exclusive or is false. I cannot do the same activity at the same time, and here also both are false, therefore I have false. So remember these two differences for inclusive or and exclusive or. Inclusive or means disjunction logical operator, and exclusive or is defined in this way: let P and Q be propositions. The exclusive or of P and Q, denoted by this symbol, is the proposition that is true when exactly one of P and Q is true and is false otherwise. That is, it is false if both are true and if both are false, and it is true if exactly one of the two propositions is true. So in this lecture we have discussed these four logical operations or connectives. First one was negation of proposition, second is conjunction logical operator, then inclusive or disjunction logical operator, and exclusive or. So remember all these compound propositions, how they are defined, and we will be using them throughout this lecture series. So this is all about this session. I hope you like it. Thanks for watching.